For this video, we are going to look at one example which is about the sketching of a transformed graph corresponding to multiple steps of transformations. At the beginning, we are given the graph of the function f, and based on this, we are going to sketch the graph of y equals to f2x minus 3. The first thing we have to do that is to compare the notations of the original function as well as the transformed function. We need to know how many transformations in total, as well as which few types of transformation we have to apply. At the beginning, we have y equals to fx, and then from the outcome, we can see that the final notation is f bracket 2x minus 3. As we can see, there are two new elements in the resulting notation. We will be able to know that there will be two steps of transformations. Then we have to identify what should be the step 1 and what should be the step 2. Usually, the first step will be related to the change inside the bracket. So we will consider this approach, that is, for the step 1, we are going to change fx to f2x. So that for the step 2, that will be representing the change from f2x to f2x minus 3. And once we identify that there are two different steps, we also need to know what would be the types of transformations from these notation changes. We can see that from fx to f2x, the change will be the multiplication of 2 inside the bracket. And this represents the horizontal compression of scale factor 2. Horizontal compression of scale factor 2 means we are kind of making the curve to be narrower. Then we look at the step 2. The change will be from f2x to f2x minus 3. And this change would mean that the graph would be translated downward by 3 units. As we know that there are two steps in total, so we can try to draw the graph that represents the step 1 first, and then later we can try to draw the resulting graph. I will first use a black dotted line to represent the step 1. As from the notation, we know that the step 1 represents the horizontal compression of scale factor 2. It represents the change that the x-coordinate would be divided by 2. Then in that case, for example, if the original point is at 4, 4, the x-coordinate will be divided by 2, which means that will be closer to the y-axis. Similarly, if I choose the point 2, 2, the x-coordinate 2 divided by 2, it becomes positive 1. Similar for origin. And on the left-hand side, if I choose the point negative 4 and 2, the x-coordinate negative 4 divided by 2, that will be negative 2. Then for those 4 points, I'm going to use two different dotted line segments to connect all of them. And then for the step 2, because we have to translate the current graph downward by 3 units. Of course, we can also refer to some fixed points. And this time, I'm going to use a blue pen. For example, if the original point is at 2, 4, because the y-coordinate was 4, then translated downward means the y-coordinate would be decreased by 3, so 4 minus 3, that would be 1. Similarly, at the original point 1, 2, when the y-coordinate is equal to 2, then 2 minus 3, that will be negative 1. And then similar to the origin, and also the point on the left. Lastly, I just need to use two blue solid line segments to connect the points. And the blue graph is the resulting graph. I'm going to give the name y equals to f bracket 2x minus 3. In the assessments, of course, we can try to use pencils to have the draft. And after we have completed the final one, we can erase the draft.